Hi everyone. Today's lesson is all about deciding how do I know what method to use. And this is an important question because right now on the table we have three possible approaches. We have solving by graphing, solving by substitution, and solving by elimination. And elimination is what we just had a refresher lesson on yesterday. So solving by graphing, obviously if you see a graph and the equations are nice and easy or already solved for y and it would be quick to sketch a nice graph, go with that. But very rarely, especially in real world scenarios, are systems of equations that nice. So this lesson is going to focus on deciding between elimination and substitution. But before we do that, we have a nice quick warm up here on elimination, and the directions specifically say to use elimination, so let's do that. So I'd like you to take a look at number 1 and make a decision on whether or not you would like x or y to cancel. The first thing I check for is to see that my variables are lined up. And if I check, my x's are lined up and my y's are lined up. The next question I ask myself is, do I have any inverses? -9 and -18? No. 4 and 2, 4y and 2y? No. Then I ask myself, well, am I close? I see here that this is a -18x. I can multiply, and -9x could become a positive 18x. When I look at my y's, this is a 4y. I could multiply and make this a -2y. These are both negative and these are both positive. So in terms of strategy, it really doesn't matter which you choose. I think I would like to get my x's to be eliminated. So this is a -18x. What's the inverse of a -18x? The inverse of -18x is a positive 18x. For this -9x to become a positive 18x, I must multiply by a -2. But I can't just say I want to multiply this one term. I have to multiply the entire equation by -2. So let's do that. Multiplying the entire equation by -2, this top would now become 18x minus 8y equals -2 times 18, which is -36. We are not going to change. We're not doing anything to the second equation. That's staying. So that will stay -18x plus 2y equals -18. Nothing has happened to that one. Line down our equal signs, line straight across. Now let's see when we linearly combine. Now we're going to be adding. Let's see what happens. 18x plus a -18x is 0. Those cancel. -8y plus 2y is -6y equals, let's see, -36 plus -18 is going to be a bigger negative number, -54. And to finish, we're going to solve by dividing both sides by -6. So I get, keep this line going, y equals, what's -54 divided by -6? Y equals 9. I have y, I need x. So we're going to go back to our original system and choose either the first equation or the second, and we're going to substitute in y. I choose the first. You could choose the second, but I'm going to choose the first. We should get the same answer. Let me write it first as a model. So -9x plus 4y equals 18. Notice I haven't actually done any substitution. I've just written the model. So I have a guide. Where I see y, we are now going to substitute 9 in parentheses. Always use parentheses. Equals 18. And now we can solve. So please pause here and finish solving for x, and we'll compare answers. I get -9x plus 36 equals 18. I'm going to subtract 36 from both sides. Now I have negative 9x equals 18 minus 36 is negative 18. And now we will divide both sides by negative 9, which results in x equals 2. My solution is 2, 9. If I was asked to check this point algebraically, what would we do? For those of us comfortable with checking, I'm totally cool if you want to jump ahead 10 or 20 seconds past the check. But if you know, like, ooh, I'm worried if she asked me this on a quiz or a test, I'm not sure if I would know how to do a check, please do this check with me. So we're going to use this as x and this as y. Let's write check right here. We're going to take the original system, so negative 9x plus 4y equals 18 is my first equation. My second equation is negative 18x plus 2y equals negative 18. And we're going to work with one at a time. Where we see x, we will substitute 2. Where we see y, we will substitute 9. So this becomes negative 9 times 2 plus 4 times 9, ooh, a little tight on space there, equals 18. Negative 9 times 2 is negative 18. 4 times 9 is a positive 36. And this right side does not change. It stays 18. Let's see. Negative 18 plus 36, that's a positive 18 equals 18. 18 equals 18. True or false? True. Check. This one worked. But remember, this ordered pair has to work in both equations. So now let's try it over here. This will be negative 18 times x, which is 2 in parentheses, plus 2 times 9 equals negative 18. Negative 18 times 2 is a negative 36 plus 2 times 9 is 18 equals negative 18. Again, this right side will stay negative 18 all the way through. Negative 36 plus 18 is a negative 18 equals negative 18. And now we ask, true or false? Is negative 18 equal to negative 18? True. I am now 100 million billion % positive that I have the correct ordered pair because when I substituted it into my original system, I get 2 true statements. Let's start answering our key question for today, which is how do I know what method to use? I'm going to highlight this title so it stands out. We're going to first discuss how do I know when I should use substitution. The key to that is right here. We will always use substitution if one or more of the variables is isolated, or in other words, already solved for. And we have 2 examples to demonstrate that. Here, if I look at number 3, notice I am given a system where one of my equations is already solved for y. Right away, that tells me, oh, I should use substitution. So let's get our titles. Solve, first sub, second sub. Let's see, is one already solved? Yes, it is. So I pull it here, and I pull it down, and I pull it right here. Y equals 2x minus 7. That is all done. No work needed. One is already solved. Next, we take the equation we did not use yet, 8x minus y equals 13. And we ask ourselves, what do I have that I can solve? What do I have that I can plug in for, x or y? Well, this says y equals. So where I see y, we will be substituting in 2x minus 7. I'm just going to move this over a little bit. Remember, housekeeping, move over a little so we have room. So I'm going to start writing my 8x over here. So 8x minus, and then in parentheses, we are going to substitute in 2x minus 7 equals 13. Notice the only variable here now is x, so we can solve for x. Pause here and solve for x, and then we'll compare answers. Distributing that negative, I now have 8x minus 2x plus 7 equals 13. I can now combine like terms. 8x and a negative 2x makes a positive 6x. And I bring down the plus 7 and the 13. We're now down to a two-step equation, so we'll subtract 7 from both sides. 6x equals 13 minus 7 is 6. And last but not least, we will divide both sides by 6. X equals 1. Now that I know x, I need to go find y. I have this equation over here that says y equals 2x minus 7. Let's use it. So where we see x, we will substitute in 1. So this becomes 2 times 1 minus 7. 2 times 1 is 2. Minus 7 is negative 5. So my solution is 1 comma negative 5. So in number 3, we had an example where one equation is solved for y. Right away I know substitution. Number 4, what do you notice about number 4? When I look at the system I'm given, how many equations are solved for y? Both. Both are solved for y. They're both y equals. So let's write our titles. Solve. First sub. Second sub. And since both of these are solved for y, it really, either one is equally a good choice. I'm going to just choose to write the first one. Y equals 3x plus 5. It's already solved, so no work to do. For the first sub, we're going to take the equation we didn't use yet. Y equals negative 3x minus 13. This says y equals. So where I see y, we will substitute in 3x plus 5. Everything else will come down, equals negative 3x minus 13. Now the key here, folks, you cannot combine like terms across this line. That's the number one thing I see people do. We must use addition and subtraction to gather x terms to the left, anything with a variable to the left, and numbers to the right. What do I mean by that? Ultimately, my goal is x equals some number. That's the goal. So to accomplish that, let's see what needs to happen. On this side, I only want variables. So what does not have a variable? This positive 5. How do we use math to move a positive 5? What's the opposite of adding 5? Subtracting 5. So minus 5 from each side. Draw a line across. This cancels to 0. So now I have 3x equals negative 3x minus 18. On this side of the equation, I only want numbers, no variables. So what can't stay here? This negative 3x has to move. What's the opposite of a negative 3x? Positive 3x. So we're going to add 3x to both sides. This cancels. On the left side, 3x plus 3x is 6x equals negative 18. To finish this, what's left? To finish solving for x, we are going to divide both sides by 6. Keep this line going. X equals -3. Last but not least, our second sub, I have x, I need y. I have an equation over here that already is set up with y equals 3x plus 5, so let's use it. Where we see x, we will substitute -3 using parentheses, so this becomes 3 times -3 plus 5. 3 times -3 is -9 plus 5. Y equals -4. So my solution is -3, -4, and we're done. As I mentioned when we had our lesson on substitution, if sticking to these concrete steps when we have a break even, remember this is a special case because they're both y equals. So this is a break even system. If you like the 3 steps and that works for you, great. Some of us, if it's easy for us to see, this says y equals, so therefore I can set these 2 pieces directly together, I'm totally okay if you jump to this step right here, where you directly just set equal 3x plus 5 equal to -3x minus 13 and solve. If what I just said makes sense to you, do that. If you're like, whoa, Miss J, what did you just say? Ignore what's written in purple and continue following your 3 steps. Good. So this is how I know when to use substitution. If one or more of the variables is already solved for. So if I have a system where one of my equations already says y equals, or already says x equals, or in the case of number 4, both say y equal, that will always be a substitution system. That would be the best approach. Now let's take a look at elimination on the back. When is it best to use elimination? Elimination is a better choice if both equations are in standard form. Standard form means ax plus by equals c. In other words, here we have 1x minus 3y equals 17. That's ax plus by equals c. Same thing, ax, -5x, plus by, in this case, minus 12y equals c. So if both equations are in standard form, we're going to use elimination. And if you look at 4, 5, and 6, these are all, every single equation in each system is in standard form. This will also be a nice practice since we just refreshed our memory on elimination yesterday. So I look, first let's check. Are my like terms lined up? Yes, my x's are lined up, my y's are lined up. Now it's time for you to make a choice. Do you want x's to cancel or y's to cancel? Well, if I look, nothing is really close yet. I don't have like a 5x and a 5x or something like that. So can we make this x be a 5? Yes. And then this would cancel. What if I wanted my y's to cancel? Well, this is a -12y. Can you multiply 3 by something to get a positive 12y? Yes, you can. Now, there still is a strategy to make a good choice. See how these are both negative? If I ended up wanting to work with the y's, get the y's to cancel, I'd have to multiply through by a negative value to make one of these positive, which is fine. There's nothing wrong with that. But if I look over here at my x values, notice how one of these is already positive. I'm not going to use yellow. Notice how one of these is already positive and one of these is negative. That's kind of nice because now I just have to worry about getting the numbers to match, not the signs. One is already opposite of the other. So I'm going to choose to work with x. this is negative 5x. I want this to be a positive 5x. So I have inverses. So I'm going to multiply the entire top equation by what? By 5. Let's see what happens when I do that. 5 times x is 5x. 5 times a negative 3y is negative 15y. And 5 times 5 times 17 is 85. We're going to leave the second equation alone. So that's negative 5x minus 12y equals negative 4. Let's check. Do I now have those inverses I was looking for? Yes. These are exact opposites. Line down the equal sign, line across. Now it's time to linearly combine them by adding 5x plus a negative 5x, 0. Let's see what's left. Negative 15y plus negative 12y is negative 27y equals what? 85 plus a negative 4, or 85 minus 4, same thing, 81. Dividing both sides by negative 27, we get y equals, what is 81 divided by negative 27? Y equals negative 3. Now that I have y equals negative 3, what do I need? I need to know x. To figure that out, choose one of your original equations from the system. I'm going to choose to use the top one, x minus 3y. Again, you could use the second, but I don't know. These are just bigger numbers. I have 2 negatives instead of just a one. I'm going to be nice to myself and choose one that looks a little more simple, I guess I would say, smaller values to work with. So if you choose to use the second one, that's fine. We should still get the same answer, okay? So if you want to pause it and run the second, we'll compare our answers in a second. Where I see y, I will be plugging in a negative 3 using parentheses. So this becomes x minus 3, and then in parentheses, negative 3 equals 17. That's x plus 9 equals 17. Subtracting 9 from both sides, 17 minus 9 is 8. And what's nice is I'm done because I have nothing that I need to divide by. So my solution is 8 comma negative 3. Let's take a look at number 5. I'm going to not talk for a couple of seconds because I want you to take a look and decide how would you approach this. I don't have any inverses, right? Like I don't have 6x and negative 6x, or I don't have a negative 4y and a positive 4y. So what would you like to cancel, x's or y's? I'm going to talk through both before I make my choice. If I wanted x's to cancel, this is a 6x. Can you multiply 2x by something to get a negative 6? Yes. I would need to multiply the entire top equation by negative 3. Could do that. If I wanted my y's to cancel, this is a negative 4y. What would I need right here? I would need a positive 4y. Okay, I'm going to choose to get my y values to cancel. I want these to cancel. So if this is a negative 4y, I need a positive 4y. So we will multiply the second equation by negative 4. Now, right about now, if you're like, no, I wanted x's to cancel, no problem. Click pause. You do your work. We should still end up with the same solution, right? Getting y's to cancel, we're not going to touch this top equation at all. So my system becomes 2x minus 4y equals 6. Not becomes, I'm sorry, it stays the same. It's staying this. My second equation becomes negative 24x plus 4y equals, and then negative 4 times 18. If you have a calculator, go ahead and do that. Negative 4 times 18 is negative 72. Now let's see what happens. 2x plus a negative 24x, that's going to stay. My y's cancel. So 2x minus 24x is negative 22x. We got our inverses here. Negative 4y plus 4y is gone. It's 0. Equals 6 minus 72, negative 66. To finish solving for x, we're going to divide by negative 22. Divide by negative 22. And my result will be x equals negative divided by a negative is positive. 66 divided by 22 is 3. I've got x, I need y, so we'll come back up to our original system. Choose either of the two equations. I think I'm going to choose to work with the first one. 2x minus 4y equals 6. Where I see x, you will substitute in 3 to solve for y. So go ahead and click pause. You solve for y, and I'll solve for y, and then we'll compare answers. Using parentheses, this will become 2 times 3 minus 4y equals 6. 2 times 3 is 6. Subtract 4y still. Bring everything else down, right? We'll subtract 6 from both sides. Minus 6 minus 6. Line straight across. Keep this going here. So I have negative 4y equals 6 minus 6 is 0. Divide both sides by negative 4. And I get y equals 0. So my solution is 3, 0. Remember, at any time, if you're not sure if your solution is right, you could say, okay, x is 3, y is 0, substitute it back into your system and do a check. Last but not least for today's notes, number 6. Take a look at number 6. What do we think? Well, right away, 1, I see that my variables are lined up, so I don't have to rearrange, which is nice. But I also notice, I think I'm going to have to do a little more work here, because here I have 4x and 5x. I can't multiply 4x by anything to get 5x. Here I have 3y and 8y. There's nothing I can multiply this 3y by to get 8y. So let's see. If I wanted my x's to cancel, the smallest number that 4x and 5x go into evenly is 20. So I would be working towards, somehow I'd be working towards a positive 20x and a negative 20x. If I wanted my y's to cancel, the smallest number that 3 and 8 both divide into evenly is 24. So that means I'd be looking to use multiplication to somehow get a positive 24y and a negative 24y. Both of these are positive, both of these are positive. So I also don't have something that's already positive and something that's already negative. So really, it's equal amount of work getting x's to cancel or y's to cancel. I think I'm going to choose to have my x's cancel. If you want y's to cancel, go ahead and work towards that positive and negative 24y, and we should still get the same answer. So go ahead and click pause. You do yours, and I'll do mine, and we can compare. To get my x's to cancel, I need a positive 20x and a negative 20x. So I'm going to choose to get a positive 20x here by multiplying this top equation by 5. And I need a negative 20x down here, so I'm going to multiply this through by negative 4. Let's see what we get when we do that. 5 times 4x is 20x. 5 times a positive 3y is a positive 15y. And 5 times 2 is 10. Here, take your time. Be very careful with distributing in the negative that you correctly distribute the negative. So negative 4 times 5x is a negative 20x. Negative 4 times a positive 8y is a positive 32y. And negative 4 times 28 is a negative 112. Line down the equal sign. Let's see what happens when we linearly combine these. 20x and a negative 20x, those are now inverses. Yay, I have inverses. These are gone. Equals 0. And now I have 15y minus 32y. 15y plus 32y is 5 plus 2 is 7. 1 plus 3 is 4. So I have 47y equals, what is 10 minus 112? Go ahead and get your calculators if you need to. 10 minus 112 is negative 102. To finish this up, we're going to divide both sides by 47. Divide by 47. And keep this line going. So 102 divided by 47 is, did I do something wrong? Let me look. Did anybody see something? 5 times 4 is 20x, 15y, 10, negative 20x. Who caught my mistake? Way back up here. Do you see it? I just found it. The reason I'm saying that is that I designed these questions to not have a decimal answer, and this came out as a decimal. So when I look, what mistake did I make right here? I did exactly what I told you guys not to do. I wasn't careful with sending in that negative. What is a negative 4 times a positive 8y? It's a negative 32y. So let's fix that real quick. Because we are working in pencil, and I have an eraser, it shouldn't be too hard to go back here and adjust. So let's see. This will be minus here, negative 32y. I'm going to back this up. Back. Let's see what we get now. 15y plus a negative 32y, or 15 minus 32. What's that? 15 minus 32 is negative 17. So negative 17y. Okay, now let's try this. Let's see. Divide by negative 17. Divide by negative 17. Y equals 102 divided by 17. I got 6. Y equals 6. Now, I do not want you guys thinking that if you get a decimal answer, you're wrong, because right after these refresher lessons, we will be working on real-world scenarios where we get decimal answers. But for these skills questions, I have designed them to work out nice because I want our focus to be on the skill. So that's why when I hit a decimal or a fraction, I was like, what did I do? So that's why I went back and I figured out what's up. In the real-world scenarios, we will almost always get decimals. So keep that in mind. But y equals 6. Yay for us. Okay, we have y, we need x. How are we going to do that? I need to go back here and choose one of my original equations. Doesn't matter which one. I'm going to choose the first one. So 4x plus 3y equals 2. Where I see y, I will be substituting in 6. So go ahead and pause the video. You solve for y. I will solve for y. I keep saying that. You solve for x, and I will solve for x, and then we'll compare. So this will be, pause. Okay. This will be 4x. If you're listening to this right now, you have already done this yourself. Where I see y, I plug in 6 equals 2. 4x plus 18 equals 2. Going to subtract 18 from both sides. That gets me 4x equals negative 16. Divide by 4, divide by 4. And I get x equals negative 4. So my solution is negative 4, 6. Now let's just have a quick 20-second discussion, big picture on what we've talked about today. in terms of what method I use, if one of my equations is already solved for y, that is immediately a substitution question. Because if I were to try to use elimination, I would have to rearrange this entire equation to get standard form first. So I would have to subtract 2x over and then make sure everything is lined up and then see what I want to cancel. It's not impossible, it's just kind of ugly. It's not pretty. We like pretty when it comes to math. What's pretty is like, ooh, check it out. This is already solved for y. So solve first sub, second sub. Same thing here. If these are both already solved for y, right away, substitution. And if you're comfortable with jumping to this step where we just set up 3x plus 5 equals negative 3x minus 13 because this is a special case, makes it even faster. I mean, not that much faster, right? So for those of us who still like solve first sub, second sub, notice, works out nice. Again, you don't want to have to be rearranging both of these into ax plus by equals c. You'd have to rearrange both. Ugly. We don't want ugly. So break-even systems where they're both solved for y, straight up substitution approach. Now, on the back, 4, 5, and 6, if I have both in standard form, which is the case in all three of these examples, elimination right away is a very nice choice because every single one of these, if I did use substitution, I'd have to solve for something. I'd have work to do here, and then I'd have work to do for the first sub and work to do for the second sub. Again, not wrong, just not working smart. Working smart means effectively approaching a question so that we do it in the least amount of time possible. For systems that are already set up in standard form, the smart choice is elimination. So that's what we're practicing today, is what's the smart choice. Very nice. So that concludes today's notes. The attached page is the practice for tomorrow's class. If you would like to get a jump start, feel free. Otherwise, have a great night, and I will see you tomorrow.